In this bonus learning objective, we're going to talk about another way to write some of our answers. It's something that's pretty important for pre-calculus and calculus. We don't necessarily need to cover it in Algebra 2, but it's something the earlier you learn, the easier it is. So a lot of times when we're dealing with domains, which is the thing we've talked a lot about this unit, is you end up writing answers like this. X is bigger than or equal to 2, x is less than -5, x is between these two values. Is there another way we can do this that's kind of more precise and less writing, which is always good? All right, so the answer to this is going to be interval notation. So it's interval, it just means if I have my number line, interval is any segment of this. So if I just shade some segment, that's an interval on the number line. So interval notation just allows me to express the shaded red region of my number line in a specific way. All right, and here's the table of what it looks like, but I'll kind of explain the main part. So the far left-hand column is the way we've been writing things is inequalities. The second column is this new thing, interval notation, which I'll explain in a second. And the third column is it written as a segment of the number line. All right, so let's start with this one here. Right. So you can see we have a segment of the number line. It's everything between A and B. All right, so when we write this as an inequality, A is on the left and B is on the right. So X is squeezed between A and B. The way we're going to write that in interval notation is like this. All right, so this basically tells me what the left-hand part of my interval is. All right, that's the left-hand part, and the right-hand part of my interval is. So it just says I start at A and end at B. And there's only one small change that happens when I have this bottom problem. At the bottom problem, the only thing that changed is now I want to include those two endpoints. I want to include A and B. The only thing that changes is now I use these square brackets instead of parentheses. All right, so I'm going from A to B. The only difference between my first example and my second example is this curve here. Let me do it in highlighter. This curve here means I have this strict inequality there. This square bracket here means I have the less than and equal to then. So curve means just less than, square means less than and equal to. But you go from left to right and just include those things. The only thing that's different on the top, if there's no ending point, if this keeps going to the right forever, there's nowhere to stop my interval. So my final answer is it starts at A, just like these other ones did. But if it keeps going forever, I'm going to use the symbol for infinity to represent it keeps going forever. And one thing, just a small note, is infinity always has the curve next to it, because you can't be equal to infinity, so it'll just always have the curve next to it. All right, so the kind of main things with interval notation is you go left to right, so the left part of your interval to the right part of your interval. If you have a less than sign, it's curved. If you have a less than or equal to, it's square. If you put all that together, you can do interval notation. All right, so our examples, we're going to rewrite things in interval notation. So this is -3 is less than x is less than or equal to 10. Okay. So my interval starts at -3 and it goes to 10. So those are the numbers that are going to go into interval notation. On the left-hand side, there's no equal sign, so that's going to be the curve. On the right-hand side, there is the equal sign, so that's going to be square. All right, so that's this shorthand way, the interval notation way of writing that interval. It's everything from -3 to 10. I'm not including -3 because it's curved. I am including 10 because it's square. Right, how about x is bigger than or equal to 2? Again, I like to think about it as number line. I have 0 here, 2 here. I want to be bigger than or equal to 2, so like 3 is bigger than 2, 4 is bigger than 2, so I'm going to be everything in this region, and it keeps going on forever. So seeing that picture helps me know that the left-hand side of my interval is 2. All right, that's where it starts. And it keeps going to the right forever, so that's where I'm going to use infinity. Infinity always has the curve because you cannot be equal to infinity. And since I have the equal sign there, I can include 2. All right, so that's the interval for everything being bigger than or equal to 2. You're starting at 2, and you go on forever after that, up to infinity. All right, write the domain of the following in interval notation. So first, let's figure out the domain the way we would have before, and then convert it into interval notation. All right, so it's a rational function, there's division, so we take the bottom and set it equal to 0, and that gives me 2. All right, so my domain is everything but x can't be 2. So how do I write everything but 2 in the interval notation? So let's look at what that would look like on a number line. Say 0 is here and 2 is here. I want to do everything except for 2. All right, so I just have this kind of blank space at 2, but everything else I want to include. All right, and one thing, whenever you have kind of a separation in an interval, you have to write it as different things in interval notation. Interval notation can only do one segment at a time. So I'm going to do the segment to the left of 2 as 1. All right, that's going to be the left-hand side. There is no left-hand side because that goes all the way to negative infinity, and it goes up to 2. Again, I can't, infinity always has the curve. I cannot use 2, right? I can't be equal to 2, so that's also going to have the curve. Right. And then the other half, I just do the right-hand side. That starts at 2. And it goes forever to the right, and that goes to infinity. Again, for the same reason, infinity always has the curve. I can't actually plug in 2 because that would cause me to divide by 0, so that's also curved. So I have to separate this into 2 separate pieces because of this kind of gap I have right at 2. And then there's this one extra symbol we need, and that's to kind of combine 2 different intervals into a single answer, is we put this little u in between them. So this means union. This is not important for you to know. It represents union. It means you're kind of combining these into one answer. All right, so when you're doing these problems on delta math, which is where you're going to end up doing them, if you have kind of multiple parts you need to put together, you put this little u between them. All right, also sometimes called a cup because it just looks like a little cup. All right, here's one for you to try on your own. All right, just going back to the inequality signs, I write this in interval notation. And this is the answer you get. All right, -8 to 22. All right, so it starts at -8, and we can be equal to -8, so it's a square bracket. We go up to 22, so that's where the right-hand side of our interval is, and we don't have equal sign, so it's a curved bracket, or parentheses. All right, so in order to demonstrate mastery of this topic, you're going to do problems on delta math, and you're going to get 8 questions right. All right, they're pretty simple, just kind of like the inequality ones we were doing, just rewriting things in interval notation, so you get used to the open or the parentheses versus the square bracket, what's on the left, what's on the right, that type of thing. Just doing practice on delta math to make sure you understand interval notation.